Hey, there we go. Let's just close Restream and a bunch of other stuff that I've got open because I think looks like we might have actually come back online. Yay! Ah, gotta love me some Australian internet there, eh? Uh, so just randomly, it seems that my internet just disconnected. It was at the NBN level. It fully dropped out. Yeah. Oh, look, Jack. Just because you learnt what press F means yesterday doesn't mean you can just use it every time. Yeah, I know that I have internet definitely working because the music's playing again. Yeah, like my NBN just cut out. Like the Telstra modem was still saying it was connected. Um, it didn't end up flicking over onto the backup. So the Telstra modem I've got's got the backup 4G in it. Not that it would have actually been a good idea for it to flick over to the 4G SIM because I think it's a capped upload speed of about 5 megasecond, which I mean, it's similar to the speed you'd be getting on NBN anyway. But yeah, it just fully crapped itself. And then yeah, like I was because everything was still saying I was still connected to the network, but I just was getting no response. I'm like, yeah, ran around, figured out like I was about to restart the modem, and then Ping started responding. Actually, I think I'm still running Ping. We don't need to run Ping anymore. All right. We can go back to our panels. I'm going to keep the Ping one there just in the background in case I need it. But yeah, and the other reason I know that I'm still online is because I'm definitely getting my little weather forecast down here, and now it's saying online with a check mark. Although I don't think it will say that if I go offline because of the modifications I've done to the way that section of the script works. Now I'm getting paranoid every time the music pauses. Like it just paused there for a second. I'm like, are we down? Like, is it dying? All right. Well, does anyone remember what we were doing before my internet crapped itself? I think we were trying to work out how we we're going to push an item up to CosmosDB. So this is what we need there. I don't really want to use a dynamic. I mean, first off, F# doesn't really support the DLR in the same manner that C# does. We're not building the Clippy extension today. We'll do that one soon. We'll do that one soon. Well, Clippy JS. I'm pretty sure that there's like just a... Yeah, here we go. You can probably just get it on NPM. Yeah, look. It's got an npm ignore file, so it's got to be available on npm. We're in total... but we're not doing that now. Okay, so automata, I'm going to put in a thing of like anyone that says Clippy. No. I just realized now my time remaining is not going to be accurate because it reset back to 2 hours. Oh well. You stuck with me for another 2 hours. Ha 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 ha. We're going to use an IAsync collector. I've made that decision. All right, so now let's come back here. We will get rid of the SQL query. Now this time we could put the partition key equals. So we could put a partition key in here, and then we would specify the field that the partition key represents on the object that we're pushing up, but we're not going to do that because we don't need to. actually, yes, no, we're not going to do that. So we don't need to put the partition key there. We're not going to call that toppings. We're going to call this order. Call it orders because it's going to be a collection. And this will be an IAsync collector of order. And that's going to be the upstream thing. And then this can just currently fail. This will just fail with not implemented yet. So it's not done yet. Because the other thing we're going to need to do is we're going to need to do like an input binding, which is the posted payload. And this will be a opportunity to come back here and let's have a look at what we do post up in the body. So we post up an object that's got a created time field, but where we actually set that server side. We have the delivery address, which has some properties, a delivery location, which is now okay. So it's really just the delivery information and the pizzas that we're submitting. So that has, again, I think, just properties that are not relevant. The order, which pizza the size, the pizza that was selected, then the toppings that we've added to it. Okay, so there's a lot of stuff here that's not, like, we don't need a bunch of this data that's going up. And yeah, I'm pretty sure the reason that it failed to do the post is because the IDs of like the pizza and the toppings and stuff like that don't match the IDs that are going to be in the Entity Framework database because we're not using that. We're using CosmosDB. Okay, easy enough. So let's create ourselves a type. We'll do a type and we'll call this submitted order. And this is going to do delivery address. Now, is there actually anything on there that I'm going to need? No, I don't need the order ID. Because so what they're using here is they're using the same DTO for the post as they're using for the storing to the database, and then they just update it. If we're going to be... So Jack's just said if it's going to be a long stream, if we're going to be stuck with me for 2 hours every time NBN resets itself. Yeah, because that'll happen fairly frequently. Maybe it's because I've actually got people like talking, so you're using bandwidth every time you send a message on here. Type delivery address. Actually, no, the delivery address I can go. Delivery address, which will be delivery address. I'm going to assume it's called that, or is it called address? It's called address. Okay. So delivery address. Yeah, because then we can just like kind of reuse these data models. Do we just use the whole order object that gets posted up? Yeah, because and then we can use partial. Then we can use. It's not a record type though, is it? So we can't do fun things like easily get the inputs from it. Anyway, for the HTTP binding, we're going to do a trigger. And how do we unpack the input binding? Yeah, like things would have gone fine if no one was here. Like if I didn't have friends. Oh, sad. Payload. That's what I care about. Payload. String categories. That's how we get that. But what if I want a complex object? Let's have a look at a post. Post. I don't have... Oh, they don't have an example of like posting with a complex object. That's okay. We'll go order, submitted order. That. Yeah. So we'll have an order that comes in. actually, and let's just do log info. We'll pipe print fn print no sprint. So let's just output like what. Let's have a look at what we're getting submitted here. It's print f order will be %a, and then we'll pass in the order. Submitted order. Okay, so we'll save that. Let's have a look. So if you've done F#, you might be familiar with the pipeline operator, which looks like this. So a pipe and a greater than symbol. Yeah, greater than symbol. So that's a pipe forward. So we're passing the output of this function as the final argument to the function that we're piping forward into. Whereas if we do the reverse one, which is less than pipe operator, so that's the inverse. So we're pushing the result of this function expression being evaluated into the final argument of the preceding thing. So this is how I can do it. I could write that way, or you could write this same line of code in F# in the inverse. So if we flip that down there, put here, and then pipe forward. So it's the same. Like this is the same intent. Sometimes, particularly with logging stuff, I tend to do the reverse pipe instead of the normal forward piping operator. So that's what that's doing there. If anyone was like, what are all these bizarre symbols that someone is introducing to my programming language? So let's restart our functions. And can I grab this post and copy as... Ooh, I can copy this fetch. So fetch. What's that look like? Neat. Let's just kill off all the headers that I don't need. So that's that. So that's all the headers. Yep. Don't need refer policy. Method post, mode cause. Yep. And then we can go HTTP. And then we will do 7071 and then API/orders, and we'll see what happens. Oh, sweet. Wait, don't I have cause enabled? Or was it because I did it that way that it didn't like that I didn't have cause? We'll use Postman. So I do curl. Oh, let's be hardcore and go curl. Copy as curl from bash. Create just a whole new window. So I don't need to be in a specific location, and I want to see as much as I can see here. And eventually Postman will load up and I will kill it. Whoa. Aw. This request is insecure. Someone should make it feel better about itself. Damn it. I can't get back to the previous to where the host is on it. So let's just paste it here first. Localhost 7071 API/ and let's just clean up a bunch of this stuff that I don't need. Just kill all that, and then it's really only the data binary that I care about, isn't it? We'll leave authorization. Yeah, we'll leave content type in there. We'll leave accepts in there. We don't need to worry about fetch there. We don't care about cookies. Cool, let's try that now. Okay, clear, paste, close that. See what we get back as a... Didn't have anything happen. We should have got a 500 response. Let's go back up here. Status 404. Oh, because it's supposed to orders, not order. Okay, well, because I'll fix that later. Totally remember to do that. Let's just modify what we got here so we post the right endpoint. We'll jump back to our correct one. Order can it be invoked from the WebJob SDK? Huh? I didn't restart the server. Or did I? No, I was sure I restarted the server. Place order, function order. Damn it, I should have done function orders. Remember that for next time. It's in there. The API order, yeah. Yeah, it should have all been there. The orders function is in an error. The method orders cannot bind parameter, submit orders to type order. Make sure the parameter type is supported by the binding. Okay, cool. I probably should have read the actual error messages that were appearing a whole bunch above me rather than just ignoring them and carrying forward. I thought that was just how you did like input bindings, or is it like from body, Azure functions, HTTP post object. Okay. This is what Google's for. Or Bing. We rely on what other people have written and then we're going to take it as our own. Okay, so that is... Yeah, they're just parsing it out as a JSON object. I thought you could do bindings on the argument. Wait. Didn't I write this? Didn't I write something around this? Tags serverless. So I've done some stuff with serverless for Slack commands, and they submit stuff up. But does that one? How was I unpacking the body? So that's Slack commands, incoming message. No, I was just unpacking the form. Get the data out of the backend database. No, because Slack commands only come up as just like as a form post. No, don't tell me I actually have to like do the deserialization myself. Post bind argument. It might not be supported. We'll have one more look into Stack Overflow. If there is, then that's obviously totally the right place to... Whoa. Button click. That's a web forms page. I wonder if that's the real password they have. Yeah, I think that I've got to just do manual parsing of it. Well, that sucks. Yeah. Yep. Looks like I've just got to manually parse the data myself. That's disappointing. Okay, well, we go let submitted order equals... Wait, it's going to be... let's have a look. What is it? Rec dot was it body dot no, we're going from a stream reader to the body. Really? Right, content. That's I think that's the v2. So that's the v1, I think. Request doesn't have content anymore. No, it's going to be use stream reader equals new stream reader on the request dot body. We're going to need to include system.io, and then we will do let submitted order equals stream reader dot, whoops, wrong desktop, stream reader read to end async, and then we're going to need to do a JSON. Okay, so raw body stream reader dot read to end async, pipe that through async dot await task, and then that needs to be let bang. So anyone again new to F sharp, so the F sharp async and the C sharp async are quite different, and they actually expose a whole bunch of different underlying types. So in C sharp, we have system.training.tasks.task, which is when we like task of T or task of generic, of task of nothing. For F sharp, we have async, which is this module here. And that's what the async keyword up here is for. It's using a computation expression to say inside of here there's going to be some asynchronous stuff happening, but because they're two different classes, we've got to do converts between them. So we use the async module from F sharp to convert the C sharp task to an F sharp async, so that we can then operate on it. So that's why I pipe forward to async.await task. So that will then give me, if we hover over this, it takes a task of T and returns an async of T, so a generic async response, but then I need to kind of wait until that's completed. Now in C sharp, we would await on task of T, and that sets up the state machine, etc., etc. In F sharp, we use a specific kind of binding. So let bang. This is just like a standard binding of like assign this variable the result of the async operation that's happening there, or the result of the computational expression let bang. There's other things like do bang, which is if you've got something that's going to return an ignore, or essentially return a void, like no response. So if that's like you're firing off like a HTTP request, and you're not waiting for, like, you're not expecting a response back, you would use do bang. You can use use has async support. So if you're getting something that is this disposable object and you're doing that asynchronously, you have use bang. Pattern matching we can do with match bang, so the result of an async operation will be then pattern matched on, and return bang if you want to return the result of an async operation. So anyway, that's what those that's what the point of the bang operator is, that you'll see in some of this stuff here. Now, so that's got me a string. If I hover over here, so yep, that's of type string. Now I need to convert it into the orders object. So we'll do let submitted order equals JSON convert. Is that what it was? JSON convert, which we need to open newtonsoft.json and then deserialize object of order. But I probably need to pass it raw body. Cool. So now we will have our submitted order. Excellent. So that should be our binding all set up, done. And if we restart our function now, hopefully we're not going to get an error. The music cut out for a little bit longer than I was comfortable with there, and I was like, oh, don't tell me I've lost the network again. Nope, all good. Oh no, my weather information has disappeared. I don't know, it's just hidden behind me. The stream's not frozen. Hey, yay! We didn't get an error. You can tell it's not frozen because it's spewing out all the response from Azure Functions. Okay, let's jump back over to that pane and run it. Let's see if we... W... 404... Oh, because I changed it to orders. Live time. I'm going to close this one. And then we want BW clear, and then we're going to paste that in so it's now on orders. And what failed this time? Executing orders not implemented. Yes, that's exactly what I wanted you to say, but I wanted a log message out before it. Execute it. Or no, order BlazingPizza.order. Yeah. So we got something. I don't know what it was because it didn't unpack. %A didn't work because it's not a record type. So I'll do %O. Actually, let's do two log. I want to put out the string as well. Order raw. That will be raw body. Who wanted to see a raw body? Wait, what are you unhappy with me for? Yeah, log information. Does not match type string. Indents are incorrect. There we go. And %O, I thought %O was unpacking the way that I wanted. Sharp string formatting, because there's like a way that I can just dump the complex object out. It would work better if I wasn't working with just classes. If I had a record type, like they would work much better. But I thought %O did like format objects using toString. Yeah. %A, yeah, that's only for record types. That's right. %O submitted order. %S. Oh, well, let's just... damn it, that's why, because this is indented. Okay, so to the Python developers on the stream, yeah, you're probably like, ha ha ha, I saw whitespace significance there and wasn't going to tell you anything was wrong. But yeah. Yeah. Wait. What kind of content? What kind of content am I showing you, Amy? The camera's above waist height. It's fine. GraphQL is just fancy OData. It's OData for JavaScript developers. It's OData for people that don't want to write XML. Raw bodies. I never said this was a safe for work stream, folks. If you had that impression, you were sorely mistaken on what you were dialing in for today. Okay, W to that one. Are we done? Yeah, I think we're done. Run curl. Wait. Yep. W1. Yeah, okay, cool. It still failed because not implemented yet, and it has unpacked everything the way that we had hoped it. You can see there's the name, there's the address. Sweet. Okay, cool. That's what we wanted. Now, this isn't going to be C sharp. Sorry, this isn't going to be F sharp optimized because we're going to keep using the C sharp DTOs back and forth. But that's okay. The point of this isn't converting it to a my real address does kind of pop up when I do autocompletes because it's saved in my profile. Yeah. Don't show your IP address, Dave. You want to remember that. Don't show your IP address when streaming, because you can use that to do like a rough lookup of where someone lives. Now, what we want to do is we want to find out. Split that. Go to the right. Go over the rip there. Now, what fields do we need to update? We need to update the current location. We need to update the delivery. Sorry, current time, created time, whatever that field is. Delivery location. We're going to need a function called get user ID. That's cool. And then smash through a bunch of the nested fields and do a whole bunch of data remapping. See, this is the problem with relational databases. It'd be easier if it wasn't relational. So we're going to go order.created time. No, submitted order. Submitted order.created time. And that will be date time.now. And of course, I don't even have system included. I didn't build the thing, Amy. The stuff on the right, like the C sharp backend. No, I didn't write that. I'm just re-implementing that in like a real language. That's it. It's getting called order because I don't know why I call it submitted order. Order.delivery location is going to be a lat long. Okay, we've already got that type, and we'll use these same two numbers that they've got there. What are they going to be? They're floats, are they? Okay, so you've worked out that's a float already. And what's this get user ID do? Oh, this is probably finding something out of the out of the current user information. So we're gonna have to fake that at the moment. It is going to be returning me a string, so we'll just have to do order dot user ID, and then that can be Mr. Awesome. And so enforce the existence of pizza.specialID and topping.toppingID in the database to prevent the submitter from making up a new so they're doing referential integrity to make sure that that stuff's there. That's probably clever. Let's do it. Okay, cool. Let's do that, but we're going to do that slightly differently because we don't have relationships, because this is CosmosDB, not entity framework. So it's a schemaless database. We can do this in a different way. We will do this by grabbing our CosmosDB binding from there. So that's going to be, that's our output. I'm going to leave the output at the end. So we will grab the CosmosDB binding. We'll use it to then get all of the specials back, so we can then do a check against what's in the database. So we're not relying on like database like referential integrity tests. We're going to have to implement referential integrity checks ourselves, which is a downside of a schemaless database. So you either make the call of whether a schemaless database you care about the potential of invalid and breaking data when you go through, or if you're not cool with that, then you have to implement your own checks, which is what we will do here because that's the way that that needs to work. So we're going to grab this as well. So we'll grab the toppings and the specials. Pizzas, toppings. We're going to tab that back to the right level. Okay. Then we will do order.pizzas. So this is just going to be updating that field. And then it removes the specials property. I'm not going to remove the specials property, but I'm going to reassign it to match ensure it is the actual valid item in the database. So we'll pipe this. Is that a seek or an array? That's a list. So that's seek dot. It's probably going to be an iter. Yeah, iter. Fun pizza. It's a fun pizza. Oh, actually, no. We'll call that SP for submitted pizza, and then we will find and we'll do let pizza. So that will be pizzas, and that is also a seek, I believe. Yep. So seek dot find. Yep. So we want to find fun p dot id equals submitted pizza dot special dot id. Yep. No, I want to try find because otherwise I'm going to get an exception back, and I don't want an exception back. And then, so that's going to return me an option. Okay, cool. So I'll write it. So what we're doing here is, because F# functional first, we have some different types that we work with to do the iterations and stuff like that. So in C# or like JavaScript and stuff like that, we might do like a for each to go over each item. In F# we use a functional approach, which are more like it's iter, which is iterate over each item and apply this function to each item in the collection, and don't get a result back. Map is the equivalent to select in C#'s link. It's the equivalent to array.map in JavaScript. And then we've got reduce, filter. So reduce is an aggregation function. Filter is like where clauses and stuff like that. So and then in F#, we have a bunch of different collection types. Same in C#. You've got arrays, IEnumerables, and stuff like that. But a lot of the C# types, all under the hood, can be treated as a neural object. So you can use the same link stuff to do functional approaches to them. So you select your filters, you select your wheres, your aggregates, etc. Whereas in F# you've got to be explicit about the type it is. So because this is an IEnumerable base type, so list of t is inherits from IEnumerable of t in the CLR. That is equivalent to an F# seek type, short for sequence. We also have array and then a couple of other collection types specifically. So that's why I was like, what type is it? It's a list. Okay, so we'll use seek there. So seek.iter, this is equivalent to doing a for each over each item. But it's a functional first way. So I could extract this out to a function that doesn't sit like kind of in line. I could have it elsewhere. So then I'm doing a seek.tryFind. So this is going to attempt to find an item that matches the predicate that I've given it, so the function, and it's only going to try and find one of those. If it doesn't, and this is then going to return me an option type. So an option type will either have a value or not have a value. If it rather than doing a find with a potential throw being given to me or something that will result in a null value coming back, I have an option type, and then I can do a match on pizza where some pizza. So when not when, it's with. Yeah, match pizza with. So when there is a pizza that was been provided, we will then do pizza dot pizza dot not pizza, sp dot special ID equals pizza dot ID, and then not equal, sorry, thinking in C#. No, it assignment, and then we'll do sp dot special will be assigned to pizza, and then we can do none. I'll do a fail with. You tried to submit a pizza we don't make. Okay, cool. So let's save that. It's just going to do a bit of formatting. So a match statement in F# is kind of like any kind of branch conditional check, but it's using pattern matching. I can do this with like an if statement, but an if statement is a bit more challenging when we're working with something like an option type. What I'm saying is this variable here, this pizza that I have, it's either going to have no value, which results down here in the fail with block, or it's going to have some value. And that some value, I'm going to then create a new local variable called pizza. I know it looks a little confusing because pizza and pizza, but in F# we define variables and we can reuse variable names in scope of where they're defined. So so this pizza option binding isn't available within inside of this match block because I called this thing pizza here. If I just called that P, now pizza is available because it's detected it from the parent scope. But because I don't care about the option type, I'm just going to rename it pizza just so it's a bit more obvious. And I don't like having like random things around like that. So yeah, we go through that. So we've updated the pizza and the special. So then in our database, we're going to have a bit more intelligence around what it looks like. And we can get back a full complex object and not have to do a whole bunch of inner joins within it. We won't do inner joins just because we don't need to really. And then we do sp. So now with the pizza, because the specials pizza that someone has said has got toppings on it. So sp dot toppings. Yep. So we're going to need to then make sure that we test the toppings as well. Then we're going to go and we will let. Okay, so then nested inside of here, we will do special pizza. So the submitted pizza dot toppings. Wait, no, that's where the closing bracket was. Toppings. So the toppings available on the pizza are going to be sig iter as well. I'm going to assume that was a list. Yep. Okay. So an iterator over that. So this is the submitted toppings. And then this submitted topping will need to find the topping from our toppings and then seek dot try find t dot id equals sp dot, I should have called it sp, topping dot id, that should be st, there we go. So we'll do that. So then we can, it's essentially the same chunk of code that we'll have up here. So we'll just copy and paste that and then rename things where is appropriate. Okay, so we're going to need to indent these. So the topping, so we're going to match the topping with topping and then st, so that topping ID is going to match the topping ID and then the topping st topping will be topping. And we're trying to submit a topping we don't have. Whoa. Close that. Okay. So this is where, yeah, I might actually pull some of this out into separate functions, because it's like, this is quite a gnarly piece of code to want to have to try and debug in the future. So let's just go oops, no, it's going to be up here inside of this module, let validate pizza. And we will need the, it'll be the submitted pizza and then the pizzas, which will be needing me to grab this code here. And we deal with everything not being indented correctly. Cool. Annoyingly, it hasn't detected the types, which is pizza. So we're going to have to explicitly type everything. And this will be a pizza special sequence. And that will actually, yeah, wait, what is the type of that? That is, yeah, it is pizza. Okay, so then instead of that, we can delete this chunk of code and we can do validate pizza, SP and pizzas. And then we can do the same with toppings. We'll create the function. Let validate toppings, and there'll be st topping, and then toppings as a topping seek. And we're going to I went too deep on that one, so it'll be here. Change some orders around. We're going to need to grab this code back, and that will be here. So the sequence iter will be valid. Oh yeah, here's where we can do validate toppings pizza. That. No. Do func st. It's trying to pizza, no, toppings, and st. Okay, so what is the type of that one? That will be a pizza topping. Pizza topping. And then we delete that. Save. Everything should reformat, and no, it didn't. So I had a bracket there. There we go. Everything is reformatted, and all is right with the world. Excellent. Okay, so that's slightly simplified it, and we could now use some partial application. Let binding. Let's validate toppings equals that. Take that outside of that loop because we don't need it. And then we can pass in validate toppings. Does that work? Bracket, no, I don't need to do that. There we go. Okay, cool. So I've just done some partial application as well. So let's just have a quick recap on all those quickly things that I did. And yes, that is totally my current location, Jack. It is a latitude 51.5001 and a negative longitude of negative 0.1239. I don't know where that is. I think it's somewhere in England from memory of looking at this app last week. Now, so you might be wondering some of the things that I just quickly did there. If we come up to this validate pizza function, it was straightforward because I just copy and pasted the code that was out there, and we pass in the pizza and the pizza special as a sequence. And yeah, unfortunately, I have to explicitly type it because it doesn't do so well at the auto discovery of CLR types, C# types, as it does with record types and types defined in F#. So it's a little bit. My code is in. Sorry, I didn't realize that Jack gave a slightly different longitude and latitude to Westminster instead of. No, you want to deliver pizzas to Buckingham Palace. I see. Okay, no, we're not going to do that. So the validate toppings function, you'll notice I flipped the arguments around. So we pass in the toppings first, that topping sequence, and then we pass in the submitted topping, so the one that was actually attached to the posted order. Now, the reason I did that is that if we come down a bit further onto line 62 here, we're able to do validate toppings. We're doing what we're calling partial application. So we're creating a new local binding, which is called validate toppings with an apostrophe on the end. And that's equal to calling the validate toppings function, but passing in only one of the two arguments that's required. So this essentially, it kind of wraps the function a bit so that it doesn't, so we don't have to always pass in arguments. So if you wanted to pre-bind an argument that goes into it, because it's always the same, in this case, the toppings are always the same. And we could do the same with pizzas, really, down here on line 65. We can. A JavaScript equivalent to this is using the bind on a function. So in JavaScript, if we do like function.bind, we can pass into this context and specify what this is going to be within inside of the execution scope. And we can then pass in arguments and pre-bind those arguments. I don't think that there's an easy way you can do that in C#. Maybe if Dave's still on the stream, he can let me know if there's an easy way to do that in C#, like the kind of partial application binding. But yeah, I don't think there is. Only way I can think to do it is you would create like an anonymous function, like using action of T or func of T. But yeah, I will. I don't know if Dave's still on the stream, because he would have been able to answer that question if he was. But yeah, never mind. All right. So here might be one of the downsides. Oh no, I've got to generate me an ID anyway. I was just thinking about what do we return now from this function, because we've pretty much got everything there. The last thing is we will go to the to orders.add order. So we're going to let's add, isn't it? I'm going to have to look at the add async. It is add async. Oh, cool. So we do do orders dot add async order. We're going to need to wrap that with brackets, and we'll do async dot await task. Cool. So that's how we can do something that doesn't return a value. So add async returns a task without any arguments to it. So it's essentially a void response. So I can do bang, and that will just say execute this. We're not going to get a result back. So you can't bind that to anything locally. So yeah, that's all cool. I haven't played with the F# stuff for .NET 5, but I believe that they've actually added a new computation expression called task instead of async, which makes it easier to do F# code against C# async operations. But yeah, like I said, I haven't had a chance to play with that yet. Maybe that'll be for a future stream. But there we go. So that will have added it to the database, and I just realized that the return of this is the order ID. So that's the output. So I need to do return what is it? OK object results, and that will be order.id. Order.id, and we'll cast that up to iasync results thing, is it? No. No, I action result. Results, yeah. So that's what we need to return. I mean, it doesn't really matter. Don't need to return that because I only have one possible return type. But I like the order ID I don't actually have yet. Like it's a number. It will be predefined as 0 because it doesn't get set, so it's uploaded. And so the downside of that is that like with Entity Framework, it would just auto increment because it's a database with auto incrementing IDs. Like it has this notion of primary keys and stuff like that. Instead, we have to assign that number ourselves, which is a little bit problematic because we don't know how many orders have already been placed. So maybe we aren't going to be able to use the C# types, or we can just do like. So we don't, like, you don't want sequential numbering of orders anyway. We will do order ID. It's going to be new random. Oops. Not that. Wow, you'd think I remember how to do random numbers in .NET. No, it is that. Okay, so let's go let ID equals let random equals that. So the random number is that. The warning it's giving me is I don't need the new keyword there because in F# you don't need new unless you're doing a disposable object. So like we're doing the stream reader up the top of this function, random, and then that will be dot next, and that will return me a number, and then what shall we put as the seed? No. Non-negative integer. Yeah, it'll be between 0 and int.max value. That'll do. Pop that there. So we've generated our new ID, which will at least theoretically be random and not an existing one. Eek. Yeah, need to think of maybe a more intelligent way of doing that. Really wish that it was I wish people would use UUIDs instead of numbers as primary keys. Damn auto increments. Okay, well, that should work. Let's restart our server. We'll sign into the portal. We'll go to the public portal. T-Max cheat sheet open anymore. Sign in here. We'll go and find our Cosmos database because I'm just confident this is going to work first time. First time for this run of it. I had a good run last time of it actually being successful and not falling apart, but we'll see. I'm feeling less confident today. We'll sign into here. We'll come to our CosmosDBs. Let's find the right CosmosDB. All of the resources, BlazingPizza. Data Explorer, yeah. Okay, loading everything up. Done. To our terminal, execute, and if it's successful, we should get a number back. Ooh! Did it? Wait, it worked first time? That's going to be the problem. It doesn't have a partition key assigned to it. It's rat. I am going to need to make my own types, I think. I'll just maybe superclass them. Yeah, and then I can partition key. Or we just pretend the partition key doesn't exist. Wow, like that worked. Is anyone else shocked? Because I am. Come on, how often does the things work the first time? Where c dot partition key equals that. Is that how I could get? No, equals null. I wonder if how do I do not it doesn't have a field. CosmosDB SQL query. Yeah, let's just go to the query engine. We'll jump down to this part of it because I'm just curious. Do I need to modify it so that we can get the keywords? So to get be able to find all orders, or can I just say where it doesn't have this field? Between distinct in top, no. I have geospatial data in there theoretically, so it's will be a little bit better. Clauses where is it working with JSON? Maybe working with JSON. Where it exists in a subquery. No. I wonder, yeah. Let's see, CosmosDB, SQL query field doesn't exist. Otherwise, I will check if a field exists in CosmosDB. It just says equals null. Where is defined? Ooh, is defined functions. System functions. Is it just going to be under a system function? Let's have a look. No, that's just datetime mathematical type checking functions. Yeah, is defined. There we go. So if we come back here and go where not is defined, partition key. Oh, there we go. That's how we can select orders without having to modify the data structure. We just got to assume that we're not putting anything else in there that has, yeah. We've got to assume that we're not putting in any other data that doesn't have that we're not going to have a partition key against, which I've got a feeling that we're going to end up doing because there's this notification subscriptions table. Track and send notification. Yeah, this track and send notification stuff looks like it's just doing. This is just mocking that you'll receive emails and push notifications and stuff like that, that's cool. I'm just wondering about this notification subscriptions collection. Where is that actually used? Notifications controller. Let's just jump forward and have a look. Where? Okay, so there's obviously a way that you can actually set up notifications in the app. Must be on my account. Phone number, email. Yeah, I'm going to assume that notifications controller is going to be called somewhere within inside of that UI. Pages, shared. No, wait, or is this just standard stuff that's in? It's in this area. That's it. Login partial. No, maybe that's just standard. Let's have a look and see if we can find where subscribe is called. Okay, yeah, here it is. Okay, yeah, so there is something that's happening down here. Yeah, this subscription. Yeah, so there is some stuff happening that we're not obviously setting up at the moment. Or yeah, it's just not being used. So that is going to add stuff to the database. So we may need to create some new data types anyway to address that, which is fine. We can deal with that in the future. My order, so let's place order. Order client, place order. Post, and that will go to HTTP. So now let's just let's connect it into here and see if it does actually work. So we go order / HTTP. Oops, no. Local host colon / 7071 / API / orders. So that will be the post there. So the order client. Oops. I want to go back to this window. So it's going to refresh that. Come back to BlazingPizzas. We're going to submit a new order. We'll see if that writes to the database. And if it does, we'll say happy... Oh, no, it hasn't started the server yet. We'll call it happy days and maybe sign off for today, because we're nearly at what I was going to call 2 hours originally. And about 10 minutes left, despite what the clock is saying due to the crash. Now maybe we're going to have to like stitch these two videos together or something annoying. Or just deal with the way that YouTube does that. Okay, so has that started? The server up? Nearly done, I think. Come on, server. Off stream, I'm going to go and do the C# version of what we've done with this particular function. Again, it's still got to push through to Cosmos and all that sort of stuff. But if you're looking at this and like you don't want to do it as F#, I'll have a C# version in there, so you can use that as the language instead and just kind of follow through. But I think so far the code has been reasonably straightforward in what it's doing. There's some new syntax if you're not familiar with F# that's happening here, such as the pipeline operators and the way that we do asynchronous stuff and the computation expressions of using like the bang on top of a binding, whether it's a let binding or a do binding and whatnot. But it's not too dissimilar sort of code to what we had originally in orders controller. If we have a look here. The other thing, obviously, that we've had to add for this one is dealing with the non-relational style of data that we get with CosmosDB versus Entity Framework. Because, it's just the difference between non-relational and relational databases. Nearly set up. Let's hope that the account's still logged in. Give it a second. There we go. Okay, cool. I'm still logged in. Oh, I can go and have a look at my past orders. Excellent. Okay, so that's where past orders come in. So we'll need to probably wire that up next week as well, so we can pull back those orders from CosmosDB. So let's add this pizza. We won't do any toppings this time. Just hit order. And we'll deliver it to to Aaron Hal at 123 Fake Street, Sydney, NSW 2000. Place order. Fingers crossed. Excellent. So it has errored because it's tried to get back that order from the database. So here's that randomly generated number, but that order doesn't exist in the database. Fair enough. But that means that it should have actually gone into here. We will go. So let's start from where c dot order id equals, and then what was the number that we had? It's general request headers. We'll grab that number. Number is that. Execute query. Look at that. Basic cheese pizza with no toppings. Ta-da! I'm pretty happy with that. It's worked just the way that I was hoping it would work. And the fact that it kind of worked straight off the bat without falling over, I'm suitably impressed with. So yeah, we might wrap it up there. If anyone's got any questions, I'll stick around on the chat for another couple of minutes. But thanks for tuning in today. I'd say apologies for the hiccup in the middle of the stream where my internet went out. It's not a whole lot I can do about that living in Australia because, well, we are on the NBN and I don't have much choice of that. I will be honest, I very nearly flicked on the 4G hotspot on my phone and changed over to run on that instead when the network went out because I had no idea how long it was going to be down for. And that would have been slightly more reliable, but probably doesn't have the streaming throughput that I get out of my home internet connection. But I hope you've enjoyed following along about how we can implement that and looking at how different data models can be supported across different styles of databases. But yeah, I said I'll chill here for a little bit longer if anyone's got questions. Otherwise, I will see you same time next week where we will start looking at like the my orders so we can retrieve existing orders and a few things around that space. Might just commit all this stuff to Git while I'm at it. Yeah. So this is, I'll just push this up to GitHub now. And like I said, I'll do the C# version off camera because it's not going to be a whole lot different to the F# stuff. It would just be syntactically a little bit different. Thanks for the boost of confidence there, Jack, saying that I managed to fumble through that version. I haven't seen you do any better. Anyway, like the C# one, I'm just going to like copy and paste it. And then add a whole bunch of semicolons because it's C# and you need to put semicolons everywhere. I wish Dave was still on the stream. There we go. Yeah, if you're wondering where it's at, it's github.com/AaronPowell/BlazerWorkshop. That's where the code's going. And there's the serverless branch is what I'm doing all this stuff on. You could actually do a Python version of this backend Jack, why don't you pick that up? You've seen the functionality that needs to be done. Let's see the Python version. Python on Azure Functions. Yeah, we'll talk offline. Hey, it could be a great PyCon talk, Jack. WebAssembly, talking to Python serverless. I have not volunteered to do that, Jack. I told some people that they should submit some stuff around the durable Python extension for Azure Functions, given that that's just been announced. So that's my job done for PyCon AU, is volunteering other people to do the work. All right, well, we might sign off there. So, again, thanks everyone for joining in. We'll be back same time next week to keep chipping away at this project and see how much further down the track we can get in terms of fully re-implementing something from ASP.NET Core onto Azure Functions.